Good morning. Today we're going to cover basic transistor construct. It's going to be done in a block form. I'm going to start out with basic diode theory, and then we're going to add an element to change that into a transistor. In the study of diodes, you learned that there are two parts to each one of these contact type diodes. One is an N, which has the electrons. The other part is a P-type material. It's positive, and it has more like hole theory, but we're not going to worry about that particular aspect. We're just going to work with electron flow on this particular example. We also learned that when you put a negative voltage applied to the N, also known as the cathode, and a P, or a plus, on the battery, connect that into the anode part, that the current actually begins to flow from the minus side of the battery, comes up as regular electron flow. It's going to go through the N-type material, and it has lots of electrons that it actually has in here, and it's going to go through the P-type material because as soon as we have what's known as 0.7 volts, the barrier potential to make this conduct is actually occurring at this point. So the electrons then flow in through the anode, and they flow around as free electrons back to the positive terminal of the battery. This is going to be the basis for our understanding of transistors. So let's see how we can actually take this device and convert it into a transistor. We're going to start out having the N, and we got a P-type material. We're going to put an N block out here, like this. And we now have a three-terminal device known as a transistor, and it actually has names for each one of these sections. This one's called the emitter. The middle part's called the base. And this part up here is called the collector. To enable this device so that it will actually conduct electricity through it, because we use these as switches and amplifiers and oscillators with lots of different kinds of applications, this needs to be forward biased between the emitter and the base. All that's needed to get this started is 0.7 volts. And this part right here, I'm going to put the minus and plus. Going to be 0.7 volts. As soon as this occurs, this transistor is now ready to conduct it, but it needs one more element. So here's the base right here. The next element is the collector. How do we set that up? The collector usually has a little higher voltage, and the reason why is because it connects into the positive part of the battery or the power supply, and it looks like this. So when we're setting this device up to get it to work, we need to put in the 0.7 volts. We call that forward biasing. And then we need to have something that's actually going to attract the electrons out of this arena right here. So while the electrons are flowing, and it goes like this, goes back down here, this particular part being set up, this also uses the same word, barrier potential, so that this part is overcome. It allows the electrons to flow up into the base, but they're going to stop there because this is forward bias, but the collector has to work with reverse bias. So and what I mean is there's an N-type material, and it's not going to connect into negative, it's going to connect into the positive part of the power supply. Now the reason why we have this is because there's an extra positive charge coming from the battery, and it's going to attract electrons across the base. So there's going to be electrons here. Some go down back into the power supply. The rest of them are going to go up into the collector. In fact, 99% of the electrons that come out of this emitter, they go through the base and they're collected up in the collector and go back into the positive part of the power supply, because opposites attract. So here's our electrons. Lots of them, they're wanting to escape. They need to go somewhere, and we happen to have a positive part on the power supply. So here they go. They're going out. They're coming back around, and the transistor is now conducting. In the next installment, we're going to take a look at this particular setup, only with the actual schematic symbol, and show you how it looks in a circuit.